Let's spend some time answering some questions from past papers, which is the best way to check your understanding. Let's start with paper 1 from November 2018. The figure shows a mid-latitude cyclone on a synoptic weather map. Question 1.3.1 says to give the term used to describe the linked mid-latitude cyclones. The linked mid-latitude cyclones is called a family or families of cyclones. 1.3.2 evidence to suggest that the mid-latitude cyclone A is the oldest. This touches on its movement. A has moved furthest eastwards, and therefore A is the oldest mid-latitude cyclone. Why is front D not associated with heavy rain? This question is testing the difference between the rainfall at the warm front and the rainfall at the cold front. So D is the warm front. It's got light rain because the gradient of the warm front is gentle. The air rises up the front slowly. The air cools down slowly as it rises, and therefore it produces light rain. It doesn't produce heavy rain. 1.3.4, what causes the dissipation or the dying out of the mid-latitude cyclone? This is the final stage of its development, and here we're going to find that the pressure at the center starts to rise, the low pressure disappears, but also the cold front completely catches up to the warm front. Last question, which is a favorite with the examiner, the impact that weather has on a torus, but specifically how that cold front is going to impact the weather at Cape Town. So here goes. Cold front brings behind it cold air. The temperature is going to decrease. The pressure is going to increase. We're going to have the formation of cumulonimbus clouds, which will produce heavy rainfall. The wind is going to start picking up and blowing stronger, and we're going to find that the wind direction changes from northwest in the warm sector to southwest in the cold sector. Paper 1, November 2020, question 1.3. Figure 1.3 shows a mid-latitude cyclone on a synoptic weather map of Southern Africa. Question 1.3.1, give evidence from the diagram that suggests that weather system A is a mid-latitude cyclone. This question is testing whether you are able to identify a mid-latitude cyclone on a synoptic weather map. So what you're going to say is that there are well-developed fronts. In other words, there's a well-developed cold front and there's a well-developed warm front. There is a well-developed low pressure. Even though the L is not shown, the pressure is well below 1,000 hectopascal. And in this case, you will notice you can, in actual fact, also speak about the fact that an occluded front has occurred. 1.3.2, why does this weather system originate at the polar front? This question is testing the initial stage and the developing stage of the mid-latitude cyclone. So the weather system originates at the polar front because at the polar front there's the converging of cold air from the polar region and warmer air from the subtropical region. Those two air masses converge and come together at the polar front. As they move in opposite directions, they create a wave or a disturbance in the polar front. 1.3.3, give a reason for the direction of the movement of this weather station. Be careful. The question is not asking you to say that the system moves from west to east as it does. The question wants to know why the movement is from west to east. And the answer is going to be that the mid-latitude cyclone is pushed eastwards or driven eastwards by the westerly winds that occur between 30 and 60 degrees. 1.3.4, why is the cold front associated with severe weather conditions? That is another way of asking you why your worst weather is experienced along the cold front. You're going to find that the cold front has a steep pressure gradient. Along the cold front, there's a rapid movement or upward movement of warm air. That air cools down very quickly, and you're also going to find that along the cold front, you are going to have the formation of cumulonimbus clouds, which will produce heavy rain and thunder, and on occasion lightning. 1.3.5, explain the formation of the stage of development shown in figure 1.3 of the mid-latitude cyclone. You need to be able to identify that this mid-latitude cyclone is in the occluded stage. The question wants you to explain how an occlusion happens, and you're going to say that the cold front moves faster than the warm front. The cold front starts overtaking the warm front, and all the warm air in the warm sector is pushed higher up into the atmosphere. Question 1.3.6 is a good question to be able to answer. Why does the cold front of the mid-latitude cyclone have a positive impact on agricultural activities in the Western Cape? Two things to bear in mind. You need to be aware of the type of weather that the mid-latitude cyclone produces, but also which favorable factors are required in order for farming to take place. The emphasis here is on the fact that your mid-latitude cyclone brings rainfall that is essential and important for farming to take place. So in this instance, there are a number of things you could say. You could say that the mid-latitude cyclone brings rain that automatically waters the crops. That rain that is brought by the mid-latitude cyclone can also be used to fill up storage dams where water can be stored for times when there is a shortage of water. That very same water can also be used to fill up other containers, other reservoirs, JoJo tanks for example. Certain crops thrive under cold conditions, and when the mid-latitude cyclone passes over a particular place and it brings the colder temperatures, those temperatures are often good for certain kinds of crops. You could even look at the fact that because agricultural activities are good, there's a good supply of jobs for people. Anything that is linked to some of the positive factors that are associated with the type of weather that the mid-latitude cyclone then brings, and how farming can benefit from those. Questions from paper 1 of November 2022, question 1.3.1 says to name the wind belt that causes the easterly movement of the mid-latitude cyclone, and that answer would be the westerly winds that drive the cyclone eastwards. It says to refer to the plan view. It says to identify front A. Front A is a cold front. 1.3.3, which one of the fronts, A or B, is moving faster? You're going to say A, the cold front moves faster than B. It says to give a reason for the answer. In other words, why are you saying that front A, which is a cold front, is moving faster than the warm front? There are a number of reasons. If you look behind the cold front, you'll notice that the winds behind the cold front are much stronger than the wind behind the warm front. So in this case, the winds are stronger, therefore it's pushing the cold front to go much quicker. Another reason is you have to look at the type of air that the front needs to pass through. Here's your cold front. There's warmer, lighter air ahead of the cold front. So when it moves through the warm air, there is very little opposition to slow it down, whereas your warm front has to move through the colder and heavy air, and that cold and heavy air slows down this front. 1.3.5 says give evidence from the sketch that the mid-latitude cyclone is found in the southern hemisphere. You're going to find that the warm sector is to the north of the weather system. In other words, this warm sector comes from the warm air that came from 30 degrees south. So when the warm sector is to the north, the system is in the southern hemisphere, and the cold sector is to the south, where the cold air comes from the south pole. This then means that the system is in the southern hemisphere. The rest of the questions is to refer to the cold front occlusion, mark C, and the cross sections. 1.3.6a, which one of the cross sections, Y or Z, represents the cold front occlusion, and the answer is going to be Z. The question then says give evidence that C is a cold front occlusion, and what you're going to find in this instance is that in this case we said Z. We see that the cold front is in contact with the Earth's surface, but you're also going to find that the temperature behind the cold front at this weather station is much lower than the temperature at this weather station ahead of the warm front. Question 1.3.6 says to explain how the cold front occlusion developed. Very importantly, all questions that say or that start with explain how or explain why have to be answered in a specific way. When you answer explain how and explain why questions, your response requires what is called a factor or a fact and a qualifier that is called a reason. So the question in this case is explain how the cold front occlusion developed. So the fact here is explaining what the cold front occlusion is and then explaining why each of those things are happening. So I've got the factor underlined in purple, and I've got the reason for why you're saying underlined in blue. So the first fact here is that the cold front overtakes the warm front, and the reason that happens is because the cold front is moving faster than the warm front. Second sentence says that during the occlusion, the warm air is forced to rise. That's part of what happens during the occlusion. That's the factor. And the reason for that is that the warm sector is becoming narrower and narrower and narrower. It's very important that when you answer explain how and explain why questions, that you have both a factor and a qualifier. When the NSC exams are marked, if you only supply a factor, you will receive a single mark for each of these sentences. If you supply a factor and a qualifier, you will receive the full 2 marks. However, if you supply no factor and only produce a qualifier, unfortunately, no marks will be assigned to you. These explain how, explain why questions can sometimes be a 4x2 question. It can be a 3x2 or a 2x2. But what's important, regardless of what the mark allocation would be, explain how and explain why requires you to give a fact or a factor, and then to give a reason for why you have stated a certain fact. And that reason is called a qualifier.